We're going to have the third presentation by Paice.
Yo.
Yeah, good. And it's about modeling friendly user interfaces. Yeah, something like that. So here you can start.
Hi. Can you hear me? Okay, cool. So, I'm Joe. Tonight, well, just a bit about me. RGB Boy on Twitter. It's not really tech-related stuff. It's more art and computer graphics stuff. And I work for Red Badger. And we're hiring, I guess. Am I meant to say that, Amy? So my talk is on modeling friendly user interfaces. In this talk, I want to present a slightly different way of thinking about your UI data model to keep your user interfaces friendly and also maintain the data integrity on the back end. It's a little bit of a disclaimer. Some of the things that I talk about in here are a little bit hand-wavy. There's some like mathematical sort of things. I'm not a mathematician. You guys will probably grill me at the end, but that's all right. Anyway, take that with a pinch of salt. Really, it's about the concepts, not necessarily the set theory. Okay, so what is a user interface? I think we should just get that clear to start with, so that we are on the same page. So for me, a user interface is generally about the user interacting with some sort of remote state. So there's something outside of the UI that generally the user is going to be interacting with and changing. There's also the UI state. So this is generally what's reflected back to the user. And then there's some sort of action. So, I mean, if anyone's used Redux, which I'm sure 80% of you guys have, this goes hand in hand there. Actions are the things that a user can do to change the UI state. There's also two other pieces. So another one of those pieces is there's generally a mapping from UI state to remote state. A good example of this would be like a post call. So in a RESTful API, you're going to be taking your UI state, posting that to the back end, and that's going to go and update your remote state. The other part is updating your UI state. So this is kind of the reducer pattern, or where you're going to take an action, the previous UI state, and you're going to compute a new UI state. Okay, so I'm going to jump into an example, because if this isn't too clear. So, loan calculator. Yeah. Okay, so we've got a little example here. When I approach UI, I like to think about what is the type of the remote state. And now, this little example here, while remote isn't going off to the server, you can kind of think about this total as being that remote data. So when I think about what is this, the remote state here, we've got a type number. Then I think about what is the UI state that I want to represent, and in this case, it's going to be the principal, so that 5,000 in the middle there, and that again is a type number as well. And then I'm going to be thinking about, okay, what actions can the user take to manipulate that UI state, and then subsequently manipulate the remote state. So here, there's two actions that you can take, which is increase and decrease, shown by the button minus and plus. There's also going to be a mapping from the UI state to remote state. So in this case, there's some sort of calculation that goes on, takes in the principal, does some work, and spits out the total. And then there's also going to be some sort of update that happens where we hit the plus button or the minus button, and we're going to update the UI state. So that's what a user interface is, hopefully. Let's have a think about what makes it friendly. So if the remote states are, if the remote states are all the possibilities of what we want the user to express. So ultimately, we want the user to be able to interact with the remote state in this kind of roundabout way. then our UI state should generally have about the same breadth, right? So the set of all remote states and the set of all UI states, if they're equal, then we know that we're getting a good translation between those and that the user can affect both. That said, also, like, because the way that the user actually interacts is through these actions, the set of actions should be equal as well. And that allows a user to be able to go within one action to go to all of the different UI states. Does that kind of make sense? Okay, getting some nods. That's good. Okay, so for me, a friendly UI is where these things are all aligned and about equal. Okay, so how does this apply to our example, or the example before? So in this case, we're talking about a couple of buttons. We've got this increase, decrease. Now let's have a little think about how the set of these things comes into play here. So this increase, decrease is quite a small number of things we can do, right? We can do two things. Whereas the number of states that we want to represent within principal is it's between the smallest principal we want, so Pmin, and the maximum principal we want, Pmax. And because of the way that increase and decrease work, it's going to be this Z here, which actually indicates it's going to be an integer. So we can only represent in this interface between the min and max principal that are whole numbers. Whole numbers? Integers. Same thing, maybe. Anyway, hand wavy. Okay, so if we then take this another step further as to, like, actually what do we want? We want to represent between the minimum total and the maximum total of real numbers. So you can see here that we've got a bit of a difference. And this means that we are going to have a little bit of frustration going on. So in order for me to go and see all of the states, well, I can't even see all the blue states, right? But if I want to see all of the green states, it's going to take me a long time to traverse through those. Okay, so how can we solve that? Or how can we increase the set of actions? So how about we change the kind of input we use? So let's have a look at the slider. So again, we've got this action. Instead of being two things, we call an update with a number. Then our UI state changes slightly, where we now have numbers, and remote state stays the same. Okay, so one thing to note here is that sliders are a little bit, what do you say, deceptive. So sliders generally clamp things. So you can see here that when I'm changing the value on the slider, we're jumping by 1,000. So you can see here that our actions are actually generally, I can do 1,000, 2,000, up to 10,000, but I can't get anywhere in between that. So again, I don't really have that larger set. And again, for the number of UI states, again, we have about the same amount. But again, what we really want is this larger set for the remote state, for the total. So you'll find that users get frustrated if their desired UI state falls outside of those allowed by the slider. So perhaps sometimes sliders work well, especially if you've got like small numbers and whole numbers and that sort of thing, but in this case, it's not really going to work for us. So what can we do? Let's change the input again. So how about we try a clamped number input? So this is one where we're going to set the upper and lower bound and not allow the state to move out of that. So here we've got actions which are going to be between, our lower principal and our upper principal, and then our UI state is going to be about the same. And you can see roughly that, like, I fudged a little bit here, again, hand wavy, that the blue is about the same, right? Like, we're going again between this min and max of the real numbers. Now, on the surface, this looks like it's going to solve our problem, right? But in reality, the actions are much less than what we thought. And this is partly because, say, a given interface like a keyboard in this instance brings its own limitations. And by typing a single character, the possible updates that we can actually perform actually make this a lot more restricted. So you can see here in the example, I'm trying to type, I've got 10,000 in there, I'm trying to type some more characters, it's not accepting those because we're clamping. So I guess maybe we shouldn't clamp. Let's get over this frustration. Okay, so how about we don't clamp? What happens now? Okay, so if we don't clamp, then we can just think that, okay, in our number of actions, we can represent the set of real numbers. In our UI state, we've got the set of real numbers as well. However, these are bigger than what our total should be. So we need to have a little think about that. So we've got this little kind of red bit down the bottom. So this is where we've kind of overshot a little bit. Okay, so how do we cater for this difference between the set of UI state and the set of remote states? So there's two options. One that the first one is that we can clamp the remote state. So in our little calculator function, when we're going from UI state to remote state, we can just drop those other numbers. Now, if you look at this little example playing on the left, you'll see that as I go above the 10,000, the total doesn't update anymore. Now, in this case, that's quite confusing to the user. In some cases, this might make perfect sense. So you could use this pattern, but in this case, it's not really going to work. So there's another option. We can increase the set of the remote states. So instead of just, there's my mouse. Instead of just restricting to this kind of min-max, we're also going to add another state, which is this invalid state. So you can see in the example as it plays, hopefully, as I go down beneath 1,000, this little question mark appears. And this is the representation of I've moved into an invalid state, and we can show that in the total. So part of the thing here is that you should make your, if you're going to add states, make them explicit. So there's still one tiny problem. So our number input says that we expect that the UI state will always be a real number. So what happens when we have 5 left in there and we want to try and remove it? In the set of real numbers, there is no nothing. So what we want to do is introduce this optional number input. And the idea here is that with a number, 0 means 0, but for optional, there's also this idea of nothing. Now 0 and nothing in this case are not the same, so we need to add that in as well. So we're going to make explicit the case for a missing value. So you can see here, again, actions and UI state, we've got the set of real numbers and the addition of nothing. So that allows us now to type where we have nothing in the field, and we can represent that. Now, the remote state didn't need to change because we just mapped that nothing into the invalid. Okay, so we currently, we're using an interface that for most users interacts via a keyboard. So if you're using this on a desktop, generally you're going to mouse into the input and use your keyboard, right? Okay, so we should definitely be aware of this. One frustration that I often have is hitting a key on my keyboard and being ignored by my computer. It happens a lot. So the example on the left, what I'm trying to do is I'm trying to type the letter A and nothing's happening. So let's move on to a text input. So if we introduce text inputs, we can allow the user to fail, right? So again, we've got these actions which allow you to update with a string, and our UI state will hold that string. So things like this will enable us to do things like copy and paste. I don't know if anyone's ever had a number field where they've gone and tried to paste into, and they've had some characters in there and then nothing happens. That's frustrating. So, so this allows the user to make full use of the actual input device, not just the one that you see on the web, on your website. There's also a hybrid approach. So once we've gone past the text, we can also combine these two things, and we can still keep the data model the same, but let's introduce a slider, and that'll allow users to quickly move between these states, and then get in there and do some more high fidelity things. So for example, we can quickly scrub, and then we can type what we need to. So it's the best of both worlds. So I'm hoping that this has given you a slightly different way to think about what makes a friendly user interface. Again, the set of remote states, get them as close to the set of UI states, and get them as close to the set of actions. Some key takeaways. Get to know the limitations of your problem. So going through that little exercise where you go and figure out the types of your remote, of your UI, of your actions, can be really useful to be able to figure out if something's going to fit well or not, and whether it's going to be friendly or not. Be aware of the transitions through the UI state. So in our button example, it was really difficult to transition through those things. Relay errors when your UI state is unmappable. So again, when we went from our UI state to our remote state, when we couldn't support things, we want to help the user get back on track. And embrace the interface your users will use. Yeah, users will use. That's done twister. Okay, so that means if they're going to be generally using a keyboard, you probably want to use a text input rather than like a number input. They will be used to using something like typing letters and things like that, and you should let them fail. That's it. Thank you.
Thank you very much, Joe. Do we have any questions?
Yes.
Hey, thanks a lot. Around the whole idea of fading, I guess the opposite example to, you're pasting something in and nothing comes out in the text field is that, let's say you have a credit card input and you put dashes in between numbers in just like a plain text input. And, if you try to interpret that as a number, that's obviously an error. Or, you put spaces in between or whatever, that's just obviously an error. And, we're all used to those kind of shitty HTML fields where you type in all the stuff, 20 fields, and then the error comes back at some point. It's like, oh, you should probably fix that. Are there any kind of general... So there's obviously a problem where text is too general for the input. Yep. Are there any kind of good strategies you found of, I guess, limiting that? Like kind of in the example, you just put a question mark there, which as a user, I'd be like, oh, okay, that's a question mark. Are there any good strategies of being friendly about that?
Yeah, so I put a question mark, but you could equally highlight the field and give a helpful error message. Also, when you're doing that mapping, so if in that, the UI state to the remote state, you can get some information about what they actually did wrong, then you can relay that back to them. So, for example, they've typed letters. So if you saw that they typed letters, you can still make it invalid, but you can also give them a nice error message that says, hey, it looks like you've got letters in here, we don't really want letters. So there's that. Also, one thing that I've often found is when you're typing in an input, generally you don't want to, when a user transitions from being okay to being not okay, you generally don't want to show that straight away, and you normally want to leave that until like you want to debounce that for a number of seconds, or once they leave the field, display that. But you can do that by, so you just increase the states that you can hold in your UI model, but then you're still protecting that UI model to state, God, what do I even call that now? Remote state. Yeah.
Great, yeah, thanks.
Cool. I think that's it.
Any other questions?
I think it's pub time.
Yeah. So thank you, Joe.
Thank you very much.